Picture this. You're standing on a mountain peak in Peru, looking down at what seems like an impossible feat of engineering. A stone road, perfectly straight, cuts through terrain that would make modern highway engineers weep. No bulldozers, no concrete mixers, no GPS systems, just human hands, simple tools, and a level of planning that puts our modern construction projects to shame. Welcome to the world of Inca road building, where they turned the most hostile mountain range on Earth into their personal highway system. The Inca didn't just build roads, they conquered geography itself. We're talking about a network of pathways that stretched over 25,000 miles across the Andes Mountains. That's longer than the distance around the entire Earth. And here's the kicker. They did it all without wheeled vehicles, iron tools, or even written language as we know it. Yet somehow, their roads were so well built that many are still being used today, 5 centuries later. But here's what really blows your mind about Inca engineering. These weren't just simple dirt paths carved into mountainsides. They built suspension bridges that could support entire armies, stone staircases that climbed straight up cliff faces, and drainage systems so sophisticated that their roads stayed dry in the rainiest season. The Spanish conquistadors, who weren't exactly known for giving compliments to the people they conquered, called these roads better than anything in Europe. The secret wasn't just in their construction techniques, though those were incredible. It was in their approach to the problem itself. Modern engineers look at a mountain and think, how do we go around this? The Inca looked at the same mountain and said, how do we make this mountain work for us? They didn't fight the terrain. They made the terrain their ally. Let me give you an example that'll make your head spin. There's a section of Inca road near Cusco where they needed to connect 2 valleys separated by a ridge that rises nearly vertically for over 1,000 feet. Modern engineers would probably tunnel through or build a massive switchback system that would take miles to complete. The Inca, they carved stairs directly into the rock face. Not just any stairs, perfectly engineered steps that account for altitude changes, weather patterns, and the physical limitations of people carrying heavy loads. The numbers behind this engineering marvel are staggering. Archaeologists estimate that the Inca moved over 20 million tons of stone to build their road system. That's equivalent to moving the weight of 200 fully loaded aircraft carriers, except they did it 1 stone at a time, often at altitudes where the air is so thin that modern visitors need oxygen masks. Some of these construction sites were so remote that workers had to carry every tool, every piece of food, and every building material for days just to reach the work site. What makes this even more impressive is the timeline. The Inca Empire only lasted about 100 years, which means they were completing an average of 250 miles of high-quality mountain road every single year. For comparison, it took the United States nearly 35 years to build the interstate highway system, and that was with modern machinery, established supply chains, and relatively flat terrain. But the real genius wasn't in the construction, it was in the surveying. Before a single stone was moved, Inca engineers had to figure out exactly where these roads would go. And we're not talking about following existing animal paths or taking the easy route around obstacles. These roads were designed with specific purposes in mind: military movement, trade efficiency, and administrative control. Every mile had to be planned with the precision of a military operation. The surveying process itself was a masterpiece of low-tech innovation. Inca engineers used a technique called line-of-sight staffing, where teams of surveyors would position themselves on ridges and peaks, using simple sighting tools to plot perfectly straight lines across impossible terrain. They didn't have telescopes or laser levels, but they understood geometry and trigonometry in ways that would make modern math teachers jealous. Here's where it gets really interesting. When they encountered obstacles, and in the Andes, everything is an obstacle, they had to make split-second decisions that would affect the entire road system. Cut through a ridge, or contour around it, build a bridge, or find a ford. Each choice had massive implications for construction time, maintenance requirements, and long-term durability, the decision-making process was surprisingly sophisticated. They'd send advanced teams to scout multiple route options, testing everything from soil stability to seasonal weather patterns. These weren't just engineers. They were part geologist, part meteorologist, and part military strategist, all rolled into one. They had to understand how the road would perform, not just in perfect conditions, but during the worst storms, the heaviest traffic, and the most demanding military campaigns. One technique they perfected was something modern engineers call cut and fill, though the Inca version was far more elegant. When they encountered a steep slope, they'd cut into the hillside to create a level roadbed, then use the excavated material to build up the downhill side. This created a perfectly level surface while minimizing the amount of material that needed to be moved. Simple in concept, but incredibly difficult to execute properly, especially when you're working on slopes that would challenge experienced rock climbers. The foundation work was where their engineering skills really showed. Every section of road started with a carefully prepared base that accounted for local conditions. In soft soil, they'd dig down to bedrock and build up with layers of progressively smaller stones. In rocky terrain, they'd level the surface and create expansion joints that allowed the road to flex without cracking. They understood concepts like thermal expansion and frost heave that weren't formally described by engineers until centuries later. But perhaps most impressive was their approach to drainage. Water is the enemy of every road ever built, and in the Andes, water comes in every possible form: rain, snow, ice, and underground springs that appear without warning. The Inca solved this with a comprehensive drainage system that included not just ditches alongside the road, but also underground channels, spillways, and even sophisticated culverts that carried water under the roadway without weakening the foundation. The stone stairs deserve special mention because they represent engineering, problem-solving at its finest. When faced with gradients that would stop most vehicles dead, the Inca simply said, "Fine, we'll make the mountain into a staircase." But these weren't random steps hacked into the rock. Each step was calculated for the optimal rise and run ratio, considering the loads people would be carrying, the effects of altitude, and the need to maintain a steady pace over long distances. Some of these stair flights were absolutely massive undertakings. The most famous section, near Qhapaq, climbs over 2,000 feet in less than 3 miles. That's like climbing the Empire State Building 4 times while hiking forward. Each step had to be carved from solid rock, shaped to provide secure footing even in wet conditions, and positioned to create the most efficient climbing angle possible. The precision was incredible. Modern measurements show that most Inca steps maintain consistent dimensions within just a few centimeters across entire flights that stretch for miles. This wasn't accidental. It was the result of careful planning and quality control that would impress modern construction supervisors. When they encountered canyons, and the Andes are full of canyons that would make the Grand Canyon look like a shallow ditch, the Inca had to get creative. They couldn't just build around these massive gaps in the landscape, and they couldn't fill them in. So they did something that required not just engineering skill, but incredible courage. They built suspension bridges. These weren't simple rope bridges like you might see in adventure movies. Inca suspension bridges were sophisticated structures that could handle heavy traffic and extreme weather conditions. The process started with harvesting materials, primarily ichu grass, a tough highland grass that grows at altitudes where most plants can't survive. This grass was processed into fibers, then twisted into cords, and finally braided into cables, strong enough to support the weight of entire armies. The engineering challenges were immense. The bridge had to be strong enough to carry loaded llamas and running soldiers, flexible enough to handle wind loads that could reach hurricane force, and durable enough to last for years with minimal maintenance. All this while spanning gaps that were often hundreds of feet wide and hundreds of feet above raging rivers. The construction process for these bridges was like watching a high-stakes circus act performed by engineers. First, they had to get those massive cables across the canyon. No helicopters, no cranes, no safety nets. The solution was both brilliant and terrifying. They'd shoot arrows with lighter cords attached across the gap, then use those to pull the heavier cables into position. Imagine being the guy whose job it was to stand on the edge of a cliff and shoot arrows into the darkness, knowing that if you missed, the entire bridge project would fail. Once the main cables were in place, the real work began. The Inca understood something that modern engineers call load distribution. The idea that you can't just hang a bridge from 2 points and expect it to work. They created an intricate web of supporting cables that spread the weight across the entire structure. Each cable had to be tensioned precisely, like tuning a massive guitar that happened to be suspended over a deadly drop. The deck construction was its own nightmare of logistics. Individual wooden slats had to be carried to the bridge site, then carefully positioned and lashed to the supporting cables. Every knot had to be perfect, because a single loose board could send someone plummeting to their death. The workers doing this job were essentially performing construction work, while standing on what amounted to a swaying ladder hundreds of feet in the air. But here's what really shows the genius of Inca engineering. They didn't just build these bridges and hope for the best. Every bridge underwent rigorous testing before it was opened for regular traffic. They'd send test loads across, first light materials, then heavier cargo, and finally a full-weight test with loaded llamas. Only after passing all these tests would they allow people to use the bridge. It was quality control that would make modern safety inspectors proud. The anchoring system was probably the most critical part of the entire structure. Those cables had to be secured to something that could handle enormous forces without budging. The Inca solution was typically elegant. They carved massive anchor points directly into the living rock on both sides of the canyon. These weren't just holes in the stone. They were engineered structures that distributed the cable tension across large areas of solid rock. Some of these anchor points are still visible today, and they're works of art in their own right. Perfectly carved stone chambers where the cables were secured with a system of knots and wedges that grew tighter under load. The more weight you put on the bridge, the more secure the anchoring became. It was like a Chinese finger trap, except instead of trapping fingers, it was holding up a bridge that people's lives depended on. Once the bridge was complete, someone had to be the first to cross it. Can you imagine that job interview? So you want to be our bridge tester? Great. Your main qualification should probably be that you're not particularly attached to living. Ooh, these test crossers weren't just showing off. They were performing a final safety check that could reveal problems that weren't obvious during construction. The maintenance of these bridges was an ongoing challenge that required incredible organization. Every bridge needed regular inspection and repair, often in conditions that would make extreme sports enthusiasts nervous. The Inca developed a rotation system where local communities were responsible for maintaining specific bridges, creating a network of specialized bridge keepers who knew every cable and knot on their assigned structures. But bridges were just one piece of the high-altitude engineering puzzle. When Inca roads climbed into the really high country, we're talking altitudes where the air has about half the oxygen of sea level, they faced an entirely different set of challenges. Up here, the weather could change from pleasant sunshine to life-threatening blizzard in the span of an hour. The paving techniques they used at high altitude were specifically designed to handle extreme temperature swings. During the day, the sun's radiation at altitude is intense enough to make stone surfaces hot enough to cook on. At night, temperatures can drop below freezing even in summer. This constant expansion and contraction would destroy most road surfaces. But the Inca figured out how to build roads that could handle these conditions year after year. Their solution involved carefully fitted stone paving that allowed for thermal movement without creating gaps or cracks. Each stone was shaped to fit perfectly with its neighbors, but with just enough tolerance to allow for expansion. It was like building a giant puzzle where every piece had to be exactly the right size and shape, and getting it wrong meant the entire section of road would fail. The drainage systems at high altitude were even more sophisticated than at lower elevations. Snow and ice presented challenges that didn't exist in the warmer valleys. Melting snow could create flash floods that would wash out entire sections of road. Ice forming in cracks could split solid stone. The Inca had to design drainage that worked not just for liquid water, but for the unique problems created by water-changing states. They built culverts, underground channels that carried water under the road, with internal dimensions calculated to handle maximum flow rates during spring snowmelt. These weren't just holes through the roadbed, they were engineered structures with smooth internal surfaces, proper grades for water flow, and outlet designs that prevented erosion on the downstream side. Snow mitigation was another challenge that required creative thinking. In some high passes, snow could accumulate to depths of 20 feet or more, making roads completely impassable for months at a time. The Inca response was typically practical. They built alternative routes. When the high road was blocked by snow, travelers could use lower altitude paths that stayed open year-round. But for the main routes that absolutely had to stay open, they developed techniques that were surprisingly effective. Strategic placement of stone walls created wind patterns that kept snow from accumulating on the road surface. They understood how topography affected wind flow and used that knowledge to literally engineer the weather around their roads. The logistics of maintaining these high-altitude roads were staggering. Repair crews had to carry their tools, materials, and food supplies to work sites that were days away from the nearest settlement. They worked in conditions where a simple cut could become infected and life-threatening, where altitude sickness could incapacitate workers without warning, and where weather changes could strand them for weeks. The Inca solved this with a system of strategically placed supply depots called tambos. These weren't just storage facilities, they were carefully planned rest stops that kept the entire road system functioning. Each tambo was positioned at exactly the right distance for a day's travel, stocked with everything from food and water to spare sandals and warm clothing. The tambo system was a masterpiece of logistical planning that made the Roman supply system look primitive by comparison. Every tambo was sized and stocked based on traffic patterns, seasonal variations, and the specific needs of different types of travelers. Military units needed different supplies than trade caravans, and both needed different support than the administrative messengers who carried information across the empire. Speaking of messengers, the Inca created something that was essentially the world's first express delivery service. The chasqui runners were athletes who could maintain incredible speeds across mountain terrain that would challenge modern marathon runners. They didn't just run, they navigated, memorized complex messages, and maintained the communication links that held the empire together. The relay system was precisely timed and coordinated. Each runner covered a specific section of road, passing messages to the next runner at predetermined points. The timing was so precise that administrators in Cusco could send a message and calculate almost exactly when it would reach its destination, even if that destination was hundreds of miles away across some of the most difficult terrain on Earth. These runners weren't just fast, they were human GPS systems with legs. Each chasqui had memorized every twist, turn, and hazard on their section of road. They knew which stones were loose, where the footing got tricky in wet weather, and exactly how long each segment should take under different conditions. Getting assigned to be a chasqui was like being selected for an elite military unit, except your battlefield was a vertical obstacle course that stretched across an entire continent. The training process for these messengers was brutal by any standard. They had to master not just running at altitude, but also complex memory techniques for carrying oral messages. Remember, the Inca didn't have written language as we know it. Every piece of information had to be memorized perfectly and transmitted without error. A single mistake could mean the difference between a successful military campaign and a complete disaster. But here's what really shows the genius of the system. They built in redundancy. Important messages were often carried by multiple runners taking different routes, creating a backup system that ensured critical information would get through even if one runner got injured or delayed. It was like having multiple internet connections, except the connections were human beings running across mountains. The physical demands on these runners were incredible. They were covering distances that would challenge modern ultramarathoners, but winded. Some people can barely at altitudes where most walk without getting chasqui routes, climb sections of Thebed over 15,000 feet, where the air has less than half the oxygen available at sea level. These guys were running in conditions where modern athletes would need supplemental oxygen just to function normally. The gear they carried was specially designed for speed and efficiency. Everything from their sandals to their clothing was optimized to reduce weight while providing maximum protection. They carried water in specially designed containers that wouldn't slosh around while running, and their messages were encoded on quipu, those mysterious knotted strings that served as the Inca version of written records. Speaking of quipu, these weren't just simple knots tied in rope. They were sophisticated information storage systems that could record numerical data, historical events, and complex administrative information. Each runner had to be able to read these devices fluently, understanding not just what the knots meant, but also the context and implications of the information they contained. The relay stations where runners handed off messages were engineering marvels in their own right. Positioned at precisely calculated intervals, these stations had to provide everything a runner needed to perform at peak efficiency: food, water, rest facilities, and backup equipment. The timing was so precise that if a runner was more than a few minutes late, the next runner would know something was wrong and could alert the authorities. But the numbers behind this entire system are what really blow your mind. The Inca were moving information across their empire at speeds that wouldn't be matched until the invention of the telegraph. A message could travel from Cusco to Quito, a distance of over 1,200 miles, in less than 2 weeks. That's an average speed of nearly 100 miles per day across terrain that would challenge modern vehicles. The organizational requirements for maintaining this communication network were staggering. Every runner had to be fed, housed, trained, and equipped. Backup runners had to be ready to fill in when someone got injured or sick. The relay stations needed constant resupply and maintenance. It was like running a medieval FedEx operation across the most hostile terrain on Earth. The cost analysis is fascinating when you think about it in modern terms. The Inca were essentially maintaining a real-time communication network that connected every corner of their empire. In today's economy, that would be worth billions of dollars, but they did it with nothing but human labor and incredibly sophisticated organization. The maintenance cycles for the entire road system were planned with military precision. Different sections required different types of upkeep depending on altitude, climate, and traffic patterns. High-altitude roads needed more frequent inspection for freeze-thaw damage. Bridge cables had to be replaced on regular schedules before they could fail catastrophically. Drainage systems required cleaning before and after rainy seasons. The labor organization was perhaps the most impressive aspect of the entire operation. The Inca had perfected something called the mitter system, essentially a rotating draft where every community contributed workers for public projects. But this wasn't random forced labor. It was a sophisticated system that matched workers' skills to specific tasks and ensured that no community was overburdened. Stone masons were assigned to sections requiring precision cutting. Bridge builders worked on the most challenging river crossings. Mountain climbers handled the high-altitude construction that required specialized skills. It was like having a massive construction company where everyone was cross-trained in multiple specialties, and project assignments were made based on both skill level and geographic proximity. The quality control standards they maintained would impress modern construction supervisors. Every section of road had to meet specific standards for width, grade, surface smoothness, and drainage capacity. Inspectors would regularly travel the entire network, identifying problems before they became critical failures. Any work that didn't meet standards had to be redone, regardless of how much time and effort it had already taken. The economic implications of this road system were enormous. Trade goods could move efficiently between regions that had previously been isolated from each other. Military units could be deployed rapidly to trouble spots, administrative control could be maintained over territories that were thousands of miles from the capital. The roads weren't just transportation infrastructure. They were the nervous system of an empire. Travel times that had previously taken months were reduced to weeks. A trader carrying goods from the coast to the mountains could complete the journey in a fraction of the time it had taken before the road system was built. This wasn't just convenient, it was economically transformative. Goods that had been too expensive to transport became profitable trade items. The military advantages were equally impressive. Inca armies could move with a speed that terrified their enemies. A rebellion in a distant province could be crushed before it had time to organize properly. The psychological impact of knowing that Inca forces could appear anywhere with little warning was probably worth more than the actual military capability. But perhaps most importantly, the road system created something that hadn't existed before in the Andes: true political unity. Communities that had been isolated for centuries were suddenly connected to a larger civilization. Ideas, technologies, and cultural practices could spread rapidly throughout the empire. The roads didn't just move people and goods, they moved civilization itself. The engineering tolerances they achieved were remarkable by any standard. Road grades were calculated to optimize travel speed while minimizing erosion. Bridge spans were designed to handle maximum load conditions with safety margins that ensured long-term reliability. Drainage systems were sized to handle 100-year flood events, not just normal rainfall. When you step back and look at the big picture, what the Inca accomplished in just 1 century of road building is almost beyond comprehension. They created a transportation network that functioned flawlessly for hundreds of years, connected the most geographically challenging territory on Earth, and did it all with technology that most people today would consider primitive. The sophistication of their planning becomes even more apparent when you consider that every major decision had to account for factors that modern engineers take for granted. They couldn't just order steel beams or concrete when they needed stronger materials. They couldn't call in helicopters when they needed to move heavy loads to remote locations. They couldn't even communicate with distant work sites, except by sending runners who might take days to deliver messages. Yet somehow, they managed to coordinate construction projects across thousands of miles of mountain terrain with precision that would make modern project managers jealous. Every stone had to be quarried, shaped, and transported to exactly the right location at exactly the right time. Every worker had to know their role in a construction process that involved hundreds of people working simultaneously on different aspects of the same project. The tools they used were deceptively simple but incredibly effective. Bronze crowbars for moving heavy stones, wooden levers that could multiply human strength by factors of 10, and rope systems that allowed small teams to lift massive blocks up cliff faces. They didn't have power tools, but they understood leverage, friction, and mechanical advantage in ways that let them accomplish things that seem impossible with hand tools. One technique they perfected was something we'd call modular construction today. Instead of building each section of road from scratch, they developed standardized components that could be adapted to local conditions. Stone blocks were cut to specific dimensions that worked with their construction methods. Drainage channels followed consistent patterns that made maintenance easier. Even the rope bridges used standardized cable diameters and knot patterns that any trained worker could recognize and repair. The quality of their stonework is legendary, and for good reason. Some Inca walls are fitted so precisely that you can't slide a knife blade between the stones, even after 500 years of earthquakes and weather. But what's really impressive isn't just the precision, it's the speed at which they achieved it. Archaeological evidence suggests that skilled Inca masons could cut and fit stones at rates that would be respectable, even with modern power tools. They accomplished this through a combination of specialized techniques and incredible attention to detail. Each stone was shaped using bronze tools and abrasive sand, ground to fit its neighbors with tolerances measured in millimeters. The process required workers who could visualize 3-dimensional fits and execute them with hand tools, all while working at altitudes that would leave most people gasping for breath. The lifting techniques they used for moving massive stones are still not completely understood. Some of the blocks in Inca construction weigh over 100 tons, and they were moved up mountainsides and positioned with accuracy that suggests sophisticated engineering knowledge. They used combinations of ramps, levers, and rope systems that distributed weight and multiplied force in ways that made impossible tasks merely difficult. But perhaps the most impressive aspect of their construction process was the logistics coordination. Imagine trying to organize a construction project where your materials had to be carried by hand across hundreds of miles of mountain terrain, where your workers lived in dozens of different communities scattered across the landscape, and where a single mistake in planning could delay the entire project by months. The Inca solved this with a planning system that accounted for every variable they could control and built in flexibility for the ones they couldn't. They tracked seasonal weather patterns to know when different types of work could be done safely. They understood which materials were available in which regions and planned their construction schedules accordingly. They even factored in agricultural cycles so that workers could be available for road building during times when they weren't needed for farming. The supply chain management was particularly impressive. Every construction site needed a steady flow of materials, tools, and food for the workers. Getting these supplies to remote mountain locations required careful coordination of llama caravans, human porters, and temporary storage facilities. They had to calculate not just what was needed, but when it would be needed and how long it would take to get there. Some construction projects were so remote that supply lines stretched for weeks of travel time. Workers at these sites couldn't just run to the local hardware store when they needed something. Every tool, every piece of rope, every meal had to be planned and delivered months in advance. The logistics planning for major projects probably involved more detailed calculations than most modern construction companies use today. The seasonal coordination was crucial because mountain weather didn't care about construction schedules. High-altitude work could only be done during certain months when conditions were safe. Bridge construction had to be timed to avoid the worst river flooding. Stone cutting was easier in dry weather, but transport was better when the ground wasn't frozen solid. They developed a master scheduling system that coordinated all these factors across the entire empire. Different regions worked on different projects at different times of year, but everything was planned so that completed sections would connect properly when they came together. It was like conducting an orchestra where the musicians were scattered across an entire continent and couldn't hear each other playing. The workforce management alone would challenge modern human resources departments. The meta system meant that workers were constantly rotating in and out of projects as their community obligations changed. New workers had to be trained. Experienced workers had to be reassigned to where their skills were most needed, and someone had to keep track of who was qualified to do what kind of work. Training programs for specialized skills were surprisingly sophisticated. Bridge builders went through apprenticeships that could last for years, learning not just construction techniques, but also safety procedures and quality control standards. Stonemasons had to master dozens of different cutting and fitting techniques. Even general laborers received specific training for high-altitude work and mountain safety procedures. The safety standards they maintained were remarkable, considering the dangerous conditions they worked in. Construction accidents were recorded and analyzed to prevent similar incidents. Work sites had specific procedures for everything from tool handling to emergency evacuation. Workers who showed signs of altitude sickness were immediately reassigned to lower elevations. It was occupational safety management that wouldn't look out of place in a modern construction company. But what really sets Inca road building apart from every other ancient civilization is how they integrated their transportation system with their broader imperial administration. These roads weren't just built and then left to operate independently. They were actively managed as part of a comprehensive system that included everything from traffic control to regular maintenance schedules. Traffic management on Inca roads was more sophisticated than most people realize. Different types of travelers had priority rights on different sections of road. Military units always had right of way, but civilian traffic was organized to minimize conflicts and delays. Trade caravans were scheduled to arrive at tambos when supplies were available. Even individual travelers were expected to follow specific protocols for road use. The maintenance system was perhaps the most impressive aspect of the entire operation. Every section of road was assigned to specific communities who were responsible for keeping it in good condition. But this wasn't just random assignment. Communities were chosen based on their proximity to road sections, their available workforce, and their specialized skills. Mountain communities that specialized in stonework were assigned to sections that needed frequent repair of stone paving. Communities with experience in rope making were responsible for bridge maintenance. Agricultural communities that had large seasonal labor surpluses were assigned to major reconstruction projects during their off-season periods. The inspection system ensured that maintenance standards were actually met. Professional road inspectors traveled the entire network on regular schedules, documenting problems and verifying that assigned repairs had been completed properly. Communities that failed to maintain their assigned sections faced serious consequences, while those that exceeded standards received recognition and sometimes reduced tax obligations. The economic model behind all this was brilliantly designed to be self-sustaining. The roads generated economic activity that more than paid for their construction and maintenance costs. Increased trade meant higher tax revenues. Faster military deployment meant lower costs for maintaining imperial control. Improved communication meant more efficient administration and fewer costly mistakes. So there you have it. The Inca didn't just build roads. They rewrote the rules of what humans could accomplish with nothing but determination and brilliant planning. 25,000 miles of mountain highways that make our modern engineering look like amateur hour. Next time you're stuck in traffic on a perfectly flat interstate, remember the guys who carved staircases up vertical cliff faces and called it Tuesday. Makes you wonder what we could build today if we had their vision and weren't afraid to think impossibly big.